some. Okay. Can't do it, huh? Nobody around you can do it either? Too many brain cells for this one, huh? Anybody else need chapter 4 slides?
Brother Scott, do you know last name Kingpin?
Yeah? Ferdy?
Birdie, yeah.
Is he uncle or no? You just know him.
Birdie.
Niece? Oh, really? Cool.
Say hi.
Yeah, he's a good guy. We went to school together here, you know. Is he with Amgen still, or what's he doing?
He's in Amazon right now.
He's working for Amazon? Oh, wow.
So he changed jobs.
Sure, Amgen was having troubles and stuff, but I don't know if they scaled back or what does he do for Amazon?
I don't actually know because when I visit him, he just moved.
Okay.
He just started his shop.
Wow. I'll have to contact him, see what he's up to. You'll have to tell me if he's ever on islands. Okay, so let's see where we got. How did you get along? Did you?
I don't think I've done a lot. I have to leave.
Good. That's very important. So to the right of this equal sign goes what? All right, atoms of oxygen. And to the left here? Zirconium-3 sulfate. We got to know what zirconium-3 sulfate is. The 3 means that the zirconium ion has a +3 charge. We can see that the sulfate on our periodic table, the back, looks like this, SO4 2-. So then we can see that the chemical formula is going to be like this. Whoops. Right? Yeah, you can go like this, and that will generally give you the value. You should understand the fundamentals behind that, though. Because of zirconium's +3 charge, it's going to take 2 +3s and 3 2- to balance out that charge, right? So this ends up adding up to 6, and that ends up adding up to 6. Okay? So we got the name, we can't get anywhere without that, so it's very good that we got that. And where do we take our wonderful information after we got it? We put it in our backpack and we go to the land of the moles. That's right. We go grams of zirconium sulfate to moles of zirconium sulfate. Okay? Here, what are we looking for in the land of the moles? Yeah, we're looking for the power of the stoichiometry, which is to relate that to moles of oxygen. Moles of zirconium sulfate to moles of oxygen. What do you think? How many moles of oxygen per mole of zirconium sulfate? What? 12. It looks like 12 to me. 3 times 4, so 12 moles of oxygen for every 1 mole of zirconium sulfate. Okay? So, how about this? Did anybody find out the mass? Or I don't even know if zirconium-3 sulfate exists. Let's find out. What's the molar mass of zirconium-3 sulfate?
Here is information from Wikipedia.
Yeah, see, it had trouble. Did anybody add up the masses?
I think it's 470.639.
You added them up, or you just... Awesome. Okay, 470.639 grams for every mole. Now, how did we get that? We had to look at the mass of zirconium, right? There's 2 zirconiums. There's 12 oxygens. Let's just put it like this. 2 zirconiums, 12 oxygens. How many sulfurs? 3 sulfurs. Sulfur is 32, so 32 times 3. 12 times 16. And then zirconium. What's zirconium? 91.2. 91.2 times 2. All right, and then we add those up, and that's where we get our 470.639. That's how many grams you need to have 1 mole of that stuff, right? Okay. After we're in moles of oxygen, where are we supposed to go now? Atoms of oxygen. Anybody uncomfortable with what to do in this sort of a scenario? What do we do when we have moles of oxygen going to atoms? What does that mean? What's that? Avogadro's number? Yes, 6.02 times 10 to the 23rd. All right? So 1 mole, 6.02 times 10 to the 23rd. Whoops. Okay, Avogadro's number times 12 divided by 470 times 2.78 should tell us the number of atoms that we get. Anybody get a number? 4.27 times 10 to the 22nd. Okay. Looks good. Should we have one more little mini review? Just a mini review. Just a mini, not on this, on the next part of what we talked about last class, right? Mini review, like this sort of business. What percentage of zirconium 3 sulfate is zirconium? And what percentage is sulfur? And what percentage is oxygen? Okay, now when we ask this, what units are we thinking about when we say what percentage is it? We're talking about what? Mass, not moles, right? Mass. So, again, 1 whole zirconium sulfate here, this zirconium 3 sulfate is 470.639. Grams per mole. All right. We can find out what of that mass is contributed by the 2 zirconiums. Put that over the total mass into times 100, right? For oxygen, what of those 12 oxygens is contributed to this 470.639? Times by 100. Take that mass over the total, times it by 100. Does that make sense? Yeah? Anybody not sure how to do this part right here? Everybody's got it? You guys got it? Sure? No. So, when we say what percentage of the different elements, what we want to know is how much mass are they contributing to the total. Do you know how we got the total there? Okay, great. So then you can take how much mass they contribute to the total. Like this. What's 3 times 32? Is that 96? 96. We can take the 96 divided by the total and times it by 100, and that'll tell us what percentage of sulfur the total is. Does that make sense? Okay, so go through, get your calculator out and try to solve these answers right here. Try to solve these answers. What percentage of this compound is zirconium? What percentage is oxygen? What percentage is sulfur? Yeah. Oh, it was 55%. It was 5% higher than I thought it would be, right? So, not bad. Yeah, we had the exam. If you're lower than 50%, then you want to think about it, how you're going to improve, right? If you're at 50%, that's great. You're on track to get an A probably. You want to kind of improve that to shore up that A. You might have not done well on some quizzes or missed some class, so you need to improve. What? Corrections in what? Okay. So, yeah, if you do better on the next midterm, like if you got 35% on this one, and you do 50% on the next one, right? It'll change that one to a 50%, right? Because it's cumulative. So now, you won't just get a better score if you really don't understand what's going on, right? So you need to, it's not a good lotto type style. You don't want to just say, well, I must do good on the final at least, right? You kind of have to gradually understand this stuff. All right, do we have some percentages here? What did we get for zirconium? Okay, 39%. Sulfur? 20%. Oxygen? 41%. Okay, very good. Now, from that information, we can identify what we call the empirical formula of a compound. Empirical formula. So from our mass percentages, we can get an empirical formula. And I want to show you how this is done, so hopefully you can be confident in this sort of thing. Okay. Now, a chemical formula like glucose up here, C6H12O6, tells us the molar ratio of the different elements in the compound. Does everybody see that? It's telling me that for every one of these units, there's 6 carbons to 12 hydrogens to 6 oxygens. That ratio can also be expressed as CH2O, right? This is the same ratio, 1 carbon to 2 hydrogens to 1 oxygen is the same as 6 to 12 to 6. Does everybody see that? It's the same ratio. But this is the actual formula for glucose. And so what we call that is the molecular formula. Whereas this, which is the simplest whole number formula, we call the empirical formula. The empirical formula. And from the mass percentage data, you can identify what the empirical formula is. Okay? Let me see something here really quick. Okay. So, let's try one of these. Here's a question here. If I have 2.012 grams of sample compound and 0.522 grams of it is nitrogen and 1.49 grams of it is oxygen, can we calculate the empirical formula for the compound? All right, can we calculate the empirical formula for the compound? So the empirical formula is going to be something like this, right? N and oxygen, and there's going to be some oxygen, some nitrogen, and some number there on the oxygen, right? That's going to be our empirical formula. Let's see. Is there anything else in this compound besides nitrogen and oxygen? Does that 1.49 and the 0.522 add up to 2.012? Yeah. It does? Okay. So that means there's nothing else. It's just nitrogen and oxygen. Right? Okay. So, from that information, I know how many grams of nitrogen and grams of oxygen. Can I just put those numbers down? N 0.522 and O 1.490. Is that okay? No, why not? What if I simplified them down to whole numbers? Would that be okay? Not, it doesn't feel good? Spirit says no? Why not? What's wrong with that? What's that? This is mass. But an empirical formula is telling us the molar ratio, the ratio in moles. So we can't just go like that. But I can find out from this information, and here's my pile of theoretical stuff, right? How many grams do I have? 2.012 grams of that stuff. I can, from the information that's there, identify how many moles of nitrogen there are in that sample. And I also can identify how many moles of oxygen there are in that sample. Right? I'll bet you there's one person in your group that can figure out how many moles of oxygen that represents and how many moles of nitrogen. Let's see. Talk to your neighbors. You better find a neighbor. You're the only one who doesn't have a good neighbor. She moved over there. She was seduced to the dark side somehow. You better head over there as well. Did anybody else not have the roll yet? Did you guys not have it yet? Okay, we're looking for moles of nitrogen. We're looking for moles of oxygen. Do I want a piano? No. You got one. Why? You guys extra? That's an odd question.
Yeah. Do you drive that Nissan?
No, we don't really very much.
Sell it?
What's that?
You want to sell it?
Yeah, we're trying to sell it.
How about I trade you?
The Nissan for the piano? We could park the piano on the sidewalk there. I guess that'd be okay. See, the thing is with the Nissan, I like it. I want to keep it. I really like it. But we do need to sell it. So we're trying to sell it for too much right now. See if anybody's buying it. So where did you get the piano?
My neighbors that moved.
Oh. Is that the,
So, yeah, they're like neighbors that live right next to us.
what's their names? The
I don't know, they're gone now. I forgot.
Clegg? No.
It starts with C. Or something. Yeah, so, their piano. Parents bought it. They didn't use it. So they're like, well, you guys can have it. I
I have a question for
Yeah.
the exam. Is there a way that we can know which questions that we are wrong?
Yes, if anybody wants to go over their exam, come into my office and we'll sit down and we'll find out which ones you got wrong and how to do them. And that is an extremely effective way to improve your understanding of stuff. So
Where's your office?
it's McKay 145, which is to the left of the security building. Somebody's trying to sell a piano back here if you are interested. Did you guys figure it out?
I feel like we're in different spots. I don't know.
I think you got, all you're missing is an equal sign, right? What are you after?
The mold,
Of?
Nitrogen.
Very good. Yeah, so write it down, moles of nitrogen. We're doing that too. We're doing both.
right number though?
I don't know, but this has to be right? This is moles of nitrogen, right? For every 1 gram. So that's right.
Do I do this?
That's okay. That's okay.
Put that?
Well, this is grams of the sample. So then you need grams of sample.
And then the grams. of
Yeah,
oxygen go here.
that'll work. That'll work too. This is grams of what? Oxygen? So, good. So this is grams of oxygen there. How many? Wait. You want grams of oxygen, but you want to convert it to moles of oxygen.
Oh, yeah.
Very good. Moles of oxygen. So how many grams are there per mole? That's what the number on the periodic table is, right? That's 16 grams per mole. Yeah, don't worry about filling in the units, or sorry, the values. Just fill in the units first.
So I've done like 3 different things. I'm not, I don't know what I'm doing. I tried multiplying that way, but I know we're supposed to do this. But this one made sense in my mind until I realized these numbers don't add up.
Add up to what?
Don't add up to that.
Well, they're not going to. This is the mass of the material, right?
Is this the right math?
I
Or
can't
is it
tell.
supposed to be
I can't, I can't tell without the units, right? You need to have the units there. So where's your line here? Show me your line. So this is grams of oxygen. Good. So then you draw a little line like this, right? Don't fight it, just do it, it's all right. 1.490 grams of oxygen. Grams of oxygen goes down here and moles of oxygen goes there.
And that's fine, right? Oh, wait.
It's not 16 moles for 1 gram, or what is it? It's grams per mole, right? This value right here, the units on this is grams per mole.
Oh, okay.
So it's 16 grams for 1 mole. Does that make sense?
Are there more steps from here?
No, because you're already in moles of oxygen, right?
Okay,
So that's
so
it.
okay, good.
She started with grams of sample, and so she's going from grams of sample to grams of oxygen to moles of oxygen. So that's great. So 16 to 1, right? Now how many grams of sample to grams of oxygen? Well, that many grams of sample has 1.042? No, 1.490. 1.490.
Oh, right here. Okay, I see. I missed the first two ones
You don't, what do you mean the first 2 ones?
because she has the sample one.
It doesn't, I mean, she started with this, but she could have started with this and just gone right there as well. But now you know how many,
So it'll be
no,
the same
it's
answer.
1.49 for every that
Oh,
amount, right?
Oh,
Yeah, it'll be the same answer. Okay. So, how many moles of oxygen? What do we start with over here? Grams of what? Okay, sample. We'll call it sample. Because we don't know what it is. But you're right, you put N on there. Now, I saw other people start with something else. Did anybody else start with something else if they wanted to go to moles of oxygen? I saw some people start with just grams of oxygen, because we already know 1.490 grams of oxygen, right? You could start at either one of those places, right? Grams of oxygen would have to go down here, right? What would go down here? Grams of sample. Very good, your NO, right? True? What goes up here? I'm hopefully getting moles of oxygen. Do you know how many grams per mole? 16. That's what's on the periodic table. That number has units of grams per mole. So this one's done. I'm already at moles of oxygen. This one, I want to go from grams of sample to what? Grams of oxygen. And then grams of oxygen to moles of oxygen. Right? How many grams of oxygen per gram of sample? 1.49 grams of oxygen for every what? 2.012 grams of sample. Right? And over here, it's again 16 grams of oxygen for every 1 mole of oxygen. Okay? What about the nitrogen? Yeah. Did anybody get a value here for moles of oxygen? 0.0931. And this one over here, moles of nitrogen. 7. Does anybody want to go over how we did moles of nitrogen? Raise your hand if you want to see how we did moles of nitrogen. Okay, so what did you start with? Did you get to write it down at all? No? Well, do you know that you would write the equal sign with the line, and then moles of nitrogen? Maybe nobody got a chance to even do it. Maybe we need to give everybody 30 seconds. Yeah. Okay, 30 seconds. There's a nice pattern over there you could follow. Okay, good. Okay, so you got moles of nitrogen. Good. Everybody get the roll? What?
I'm confused because this is how I set it up. This is how I set it up.
Yeah, both of them could get you the same location,
I got
right?
a different number.
Well, this is the problem here. Nitrogen is not 16. Nitrogen is 14. Or that's
yeah.
a contributor to the problem, if not the
So
problem.
should I
Yeah.
not change it to put just 14? Should I put like the point zero?
No, that's not a big deal. No, it's okay. Either one's okay.
Yeah, I think you. My neighbors love
Uh-oh.
nitrogen.
Are you getting it?
I know.
Good. You guys got it? All three of you? All right. You guys okay? Got it? Excellent. Okay, so that's grams of nitrogen.
Yeah, I kept this one.
This is grams of sample.
Yeah.
Okay, great. So you're going to go grams of sample, grams of nitrogen. Very good.
And then this is like 1 mole nitrogen.
Mm-hmm.
And then 14.
Mm-hmm.
6, 7, 4 grams of nitrogen.
Very good.
So it's just how to
Mm-hmm.
Okay.
Very good. Yeah.
When I first started, I put Avogadro's number there. I'm just kind of confused about how you know when to use the periodic table number.
Well, you just have to kind of understand the units that we're after.
Okay.
So in this one, we want moles of material, right?
Yeah.
So if they were talking about the number of whatever the things that you're talking about, if I have this many moles and I want the number, that's when you use Avogadro's number, right?
If you have this many moles going into like the number
Whatever
of
it is.
okay. But when you're trying to find the moles is when you use like how many grams.
I mean, it depends, because, you might start with atoms or something else, and then you got to get to moles, right? So it just depends on where you're at. But if you see that you need to go from grams of oxygen to moles of oxygen, then you need to think, what is that relationship? Well, that's that number up there, grams per mole, right?
Okay.
And for molecules or compounds, you have to add up all the masses to get the moles. Any luck?
I'm starting to understand.
Okay.
What we're doing is then what's the lowest ratio?
Okay, yeah. I don't think we're going to go through that slide directly just like that. We're answering this question on the side. All right, so hopefully we're all in a place where we can identify how many moles of nitrogen and moles of oxygen. Then, once we have the moles of nitrogen, 0.0373, and 0.0931, this is a molar ratio, right? It's not a whole number yet, but this is it. This is the molar ratio. So this is the empirical formula almost, right? How can we get these into whole numbers? You might be able to see, oh yeah, it's 1 to 7 or 2 to 3 or something like that already. But if you can't see it, one thing you can do is, this is 0.03, right? One thing you can do is you can divide both of them by the lowest number. Because what that does is it'll force this one to 1, right? So now you got one of them as a whole number. What number does it give us for the oxygen if we do that? All right, pretty close to 2.5, 2.49, something like that, right? Okay, so I think that gets us closer. We're still not there, but I think we can tell what we need to do. What do we need to do now? Multiply everything by 2. So N2O5 ends up being our empirical formula. So from information about the masses, whether it's masses like this or percentage of masses, we can get an empirical formula. Now, what was the difference between the empirical formula and the molecular formula? The empirical formula was what? They're both moles. They're both moles. That's right. Empirical and molecular. But here, let's go back to this one. Question? What's that?
I was just gonna say that.
So what is it? What's the difference between the empirical and the molecular?
Empirical is the smallest ratio, and the molecular is the actual.
Yes, very good. The molecular is the actual ratio for all those given molecules. Very good. So here's an example. Glucose. This is the chemical formula for glucose, right? It means that in every molecule of glucose, there's that many carbons, hydrogens, and oxygens in that ratio. If you reduced it down, this would be the chemical empirical formula, right? There's not 1, 2, and 1 of these atoms in units. But the ratio is 1 to 2 to 1, right? So between the empirical formula and the molecular formula, there's a multiplier, a value that you can multiply by to get from the empirical to the molecular formula. What's the multiplier here in the case of glucose? 6. You have its empirical formula, multiply all the subscripts by 6, and you get the molecular formula.
So for molecular, would you want to find the greatest common, like the greatest common factor, basically, or would it matter the whole number that you use that's in all?
Yeah, it matters the whole, let's see, so the multiplier?
Yeah.
Yeah.
Does that be the highest you can go that's similar?
No, because I mean, you can go out forever, right? You can go higher, and you just put any multiplier in there, and the ratio will still be the same. The way you find the molecular formula is you actually need to have information about the molar mass of the material. That's the only way you can find the molecular formula from the empirical formula.
So what we just solved for is
Empirical formula, that's right. Now, there's no reason that it doesn't mean that you can't have the same molecular formula, right? So like water, H2O, is that its empirical formula or is it its molecular formula? Both, right? Because you can't get it down any lower. You can't reduce it anymore. So we could be at a molecular formula already. We just don't have any more information. So when you get a problem like this one, now see, I told you we were going to spice it up a little bit. You guys ready for this? You guys ever done Kahoots?
Yeah.
Okay, get out your phone. Go to kahoot.it. What's the what? Integer ratio?
Yeah.
That's like your multiplier. It's some number.
Okay, so, for the one that we just did, the N and the O, would I say like integer?
Oh, integer ratio there, they're talking about 2 to 5.
So it would be 2 to 5?
Yeah.
Okay, I was just like making sure.
Okay. 32266. Hopefully this thing is still working. It's not? Ugh. You sure it's not working? What's it say?
We have to like restart it.
Yeah, so like restart the game.
Okay, put your names in. Who's BS? I'm gonna kick you out.
No, that's my initials.
That's my daughter's and my son's initials too.
It's really unfortunate.
96073. Okay, so see, this is the problem with this dumb thing, right? We already did these, remember? Good. Did you get it? You gotta go fast. You gotta go really fast. Sorry. Ooh. Nickname got it, huh? We're trying to move forward in the quiz to where we're at, right?
Still in the lead.
And I had it already tuned for prep for that. I don't know. Do you guys remember this one? Maybe you don't remember this one. What's not loading? It's not working? It's going now? Yeah. This is a little bit of a review. Remember how to do this one? 35.
Wait a second. If I get the highest score, can you sell me your pizza?
For the right price, not for a piano. Okay. Here it is. This is the question that we're after. The empirical formula for hydrazine is NH2, and its molar mass is 32. So from that, you should be able to identify what the molecular formula is. The molecular formula. Empirical formula, NH2. Empirical formula, NH2. And to go from the empirical formula to the empirical mass, there's some multiplier, right? Times some value. Just like if you want to go from NH2 to whatever it actually is, there's that same multiplier. The empirical mass is what? What's the empirical mass? What's the molar mass? What's the molar mass? 32? Let's see. 16? 16 is the empirical mass. And the molar mass is 32. Empirical formula, NH2. So what's the molecular formula? N2H4. Right? Can you see that? All right.
Yes.
Yeah. So, the empirical formula NH2, right, relates to the molecular formula through this multiplier. So the empirical formula NH2 relates to NXHY through some multiplier, right? Just like the empirical mass relates to the molecular mass through a multiplier, the same multiplier. We're given the molecular mass. What was the molecular mass? 32, and we can determine the empirical formula, or mass. How do we determine the empirical mass? It's the mass of that. Empirical mass is the mass of the empirical formula. Good, 16.
So 16 divided by 12.
16 times 2 gets us to 32, so these have to multiply by 2 to get us to our empirical formula. All right, all done for today. We'll see you guys on what day? Monday?